Okay, 5.4, number 16. Let's take a look here. Homework problem. What are the dimensions of the lightest open-top right circular cylindrical can that will hold a volume of 1,000 cubic centimeters? All right, we can go back and compare to example 4. I might leave that to you, but we're going to definitely find this out. What are the dimensions of the lightest, well, the lightest open-top right circular cylindrical can? It will be based on the area of the can used. So I've gone ahead and drawn this, illustrated that we're open here, and we would have, so we're open on the top, and we're using a radius and a height. Now the area of material we're using would include the circle on the bottom, pi r squared, plus the area of the lateral area, which would be 2 pi r, that's the distance around here. Just imagine if we took this and we sliced it up a side and rolled it out, it would just be a big rectangle. Where this would be 2 pi r, if I sliced this straight down the can, rolled it out, it would be a rectangle, and this would be h. So 2 pi r h represents the area of the side of the can. There is no top, so just one circle. Volume of a cylinder is base, which in this case is pi r squared, times height. So let's work from there. We also know that we want a volume of 1,000 centimeters cubed. Okay, let's create some space here, get all this mess out of my way, and let's get at it. Okay, so this is our volume. Our volume is very easy to solve for h. So I'm going to go h is 1,000 on pi r squared. Our area is in terms of, right now this is a function in terms of r and h, but I can replace h with this function of r. So area with respect to r is pi r squared plus 2 pi r, replace h with times 1,000 on pi r squared, or pi r squared plus, let's see, we'd get 2,000 on, pi's cancel, one of the r's cancel, on r. So there's area with respect to r. Let's find our derivative. That would be 2 pi r plus, if this is r to the negative 1, that would be negative 2,000 r to the negative second, or on r2, or we get 2 pi r minus 2,000 on r squared. We set that equal to 0. I'm going to multiply both sides by r squared. Little easy algebra here, and I get 0 equals 2 pi r cubed minus 2,000, or 2 pi r cubed equals 2,000, or pi r cubed equals 1,000, or r equals 1,000 divided by pi, take the third root of, and I get r is 10 on the third root of pi. Well, that worked out pretty nicely. Let's see what they're asking for. What are the dimensions? So that's r. I need h. So we come back up here. Here's h. So can we see that? I'm just going to rewrite it down here. H is 1,000 on pi r squared. And now I can make that h is 1,000 on pi times 10 on the third root of pi squared. So that gives us h equals 10,000 on pi times 100 on the third root of pi squared, or h equals 1,000 divided by 100, that would be 10. I'm going to move this Ooh, is that what I want to do? Yeah, I think so. I'm going to move this guy to the numerator. Multiply that. 100 stayed in the denominator. So I get third root of pi squared all on pi. Oh, a little simplifying here. Let's go 10 pi to the 2/3 all on pi. Or 10 on pi to the 1/3. So there's h. Dimensions. A little bit messy here. Not unusual for me. And I'm feeling pretty good about that. Okay, hope that was helpful. We could take a look at a calculator on that one, but we're in pretty good shape here.